So with trigonometry, or the basics of trigonometry, or the topic called SOHCAHTOA, as some people know it, or as most people know it, to be honest, it's all about being able to work out side lengths and angles in right angled triangles. So if I have, for example, a right angled triangle like this, where the right angle is labeled here, and let's just say I have some angle, and I'm just going to say 57 degrees, just for argument's sake. The side lengths have names. Now, if you've done Pythagoras' theorem, you may already know what one of the side lengths are called. Do you have any idea of what the side lengths or any of the side lengths are called?
I know one of them is called the hypotenuse.
That's very good. Do you know which one the hypotenuse is?
The one opposite to the right angle.
Ah, yes, even better. Most people would just opt for the longest side, which is true, but you've actually gone further and said the one opposite the right angle. So I'm just going to write hype for short, but it's the hypotenuse. Now, the other side lengths have names as well. And the names of those side lengths depend on the positioning or the placement of this angle. Okay, so this name here is called opposite because it's opposite the angle that we're working with in the triangle. Then with this next one, we've got adjacent because it's adjacent to the angle that we're working with, or next to the angle, or what adjacent means. So the full words are over here. Opposite, adjacent, and hypotenuse. So the hypotenuse, as you mentioned correctly, is always opposite the right angle, and the opposite is always opposite the angle that we're interested in, and adjacent is always next to the angle we're interested in. Another way you can think about adjacent is it's always in between the angle we're interested in and the right angle. It's always in between these two. Is that all good so far?
Yeah.
Okay, so just as a little exercise then, I'm going to draw 3 triangles, and I'm just going to get you to practice labeling these triangles. Do not watch my sketching skills. Okay, so I'll let you think about what these are. Oops, it's not even a straight line. Oh, you're already at it. Nice, that's good. So I'll just let you have a go at that. And I'm just going to prepare some questions. Okay. These are the questions we'll work on. Awesome. Okay, so let's have a look at what we've done here. So with the first one, you've got the hypotenuse here. Great, it's opposite the right angle. Ooh. Oh dear. Then this here is opposite the angle. That's good. And then adjacent is in between the angle and the right angle. So this one is nice. This next one, the hypotenuse, great, it's opposite the right angle. And then the adjacent, question, is that adjacent in between the angle and the hypotenuse? I'm sorry, the angle and the right angle?
Yeah.
Is it? Our angle is 46 degrees. Is this placed in between?
Oh, no.
Yes, and this opposite, it's not opposite this 46 degrees. You see? You understand where opposite should be?
Yeah.
So I'll just let you change that. Nice. Then we've got opposite. So in this next one, the opposite is opposite the 59 degrees. And the adjacent is, in fact, next to the 59 degrees, or in between 59 and the right angle. And the hypotenuse is opposite the right angle. So is that okay so far?
Yeah.
Okay. And then I'm just going to really quickly introduce to you the three trigonometric ratios on slide 2. So they are sine of something, cos, and tan. Now, these are all trigonometric ratios that allow you to work out angles and sides in right angle triangles. Notice how I've put brackets and I've put dot, dot, dot. Inside, in the case that we're using it, it's always going to be an angle inside. So it's going to be sine of an angle, cos of an angle, or tan of an angle in some way, shape, or form. So let me show you what I mean by that. So we have a right angle triangle, and I'm just going to label one of the angles just angle. So this is our angle. So if we label this triangle, this would be opposite because it's opposite the angle. This would be adjacent because it's adjacent to the angle. And this other one will be hypotenuse. All good so far?
Yeah.
Nice. Now, a good way, now where does this whole Sokotoa thing come from? Well, it comes from this. Notice how I've spelled Sokotoa. So you can turn these into little formula triangles. Yes, these are formula triangles. Please don't judge my drawing of triangles. Is that okay?
Yeah.
Then, so O really stands for opposite. So opposite, opposite. A really stands for adjacent. So adjacent, adjacent. So what do you think? Oh, and H stands for hypotenuse. What do you think the S, C, and T stand for?
sin, tan, and cos.
Yeah, it stands for those, exactly. Just making more space. So, and in particular, there was one thing that I mentioned at the beginning, and it's written at the top. You say sin, tan, and cos. Is it just sin, tan, and cos, or does it come with something?
It's multiplied by an angle.
It's of an angle. It's not multiplied. It's actually a different function altogether, but I get what you mean. So sine of angle. And then you've got cos. Oop, and then tan. So cos of angle and then tan of angle. Okay. So these relationships, we will use them to actually work out side lengths and angles in questions. It seems very abstract right now, but go with it for now. On the next page, I'm going to draw those triangles again up top. And as you use these triangles more and more, you will remember them. So don't worry too much about trying to memorize them for now. Just keep referring. In fact, what I'll even do is I'll make sure that I have this at the top of every page for questions that we do. So with the questions that are on slide 3, just whilst I'm preparing the next slides, I want you to have a think about just labeling the side lengths of each triangle. So just you can put like hype, op, edge next to each side length if you dare. Okay, I've made quite a few copies. I'm just going to prepare some more questions as well. Yeah, we'll see of how many of these we need to do. Cool. Okay. So I'm going to go back. Oh, wow, that was quick. Wow. Yeah, you labeled it perfectly, it looks like. So just going to check. So the opposite is opposite the 35. Hypotenuse, yep. And the adjacent. Opposite the 40, yep. Adjacent hypotenuse. Opposite, adjacent, hypotenuse. Nice. You got this. Okay. Now, with the first question, part A, let's focus our attention on that. We know the opposite is 10 centimeters, right? And we're trying to work out the adjacent because it's given as X. So, question, Of the three triangles at the top, the red triangles at the top, which triangle has both opposites and adjacents in it?
The last one.
Yeah, the last one, the TOA triangle. So we're going to use this TOA triangle. Okay. So what we're actually going to do is this. Now, question, rather than writing T, O, and A, we're going to write what they actually are. So what is T?
Tan angle.
Yes, tan angle. And in this question, what is the angle?
35 degrees.
Very good. So 35 degrees there. Okay. And then in our next bit, so let's go for O. What is O?
10 centimeters.
Very good. Then we've got X. Well, I kind of told you the answer. I wasn't supposed to do that, but I mean, if you were able to get the first two, then I think I trust that you would have gotten that one. So the last bit, the adjacent, is X. So I'm writing that there. Is that okay?
Yeah.
Cool. And the thing that we're trying to work out is X. So if you're familiar with formula triangles, are you familiar with formula triangles?
Yeah.
Cool. So if I say X equals, from that formula triangle, what can we say X is equal to?
10 over 35.
Yeah, 10 over what, sorry?
35.
Not just 10 over 35, but 10 over tan 35. Okay, so we cover up the X and then we're left with 10 at the top and then the tan 35 at the bottom. So X equals 10 over tan 35, like that. Then it just becomes a question of putting it in our calculator. And in this case, that gives us, in fact, do you have a calculator? I want to see what answer you get. And then we can compare.
I got 14.281.
Oh, sounds good. Yeah. 14.28148007 and so on. So we can say X equals, let's say, 14.3 to 1 decimal place. So that we've gone through the process of trigonometry there just to work out a side length. How is that for you?
It seems all right.
It seems all right. I think hopefully we can get that from it seems all right to I'm confident with it by the end of this lesson. So if we go for the next one, next question, again, you've correctly labeled the side lengths, which is good. So let me ask you the question. Which side length are we trying to work out?
The hypotenuse.
Mm-hmm. And then which side length are we given?
The opposite.
Mm-hmm. So therefore, we're now looking for the triangle at the top that has hypotenuse and opposite. Does that make sense?
Yeah.
So which of those three triangles at the top has hypotenuse and opposite?
The first one.
Yeah, the first one, the soh one. Emphasis on that H. So that's the one there. Okay, so that's the one that we're using. And inside that triangle, what am I going to put in each section?
In the bottom left one, you need to put sin, and then in brackets 4c.
Yep. Very good. So, yeah, it's going to be sin 40 or sine 40. Cool.
And
And
then
then,
the top triangle, you need to put 8 centimeters.
very good, because that's the opposite.
And then the last the last one, you need to put x.
Yeah, just x. And the thing that we're trying to work out is
The hypotenuse.
which is the x. So we would say, what would we write next?
X equals 8 over sin 40.
Very good. And then getting out the calculator. So I'll wait for you to tell me your answer.
I got 12.4 to 1 decimal place.
Okay, sure. So 12.4457. Yep, so x equals 12.421 dp. Lovely stuff. So then, okay, next I'm now going to just give you a bit more time now to try this next question. Is that okay?
Yeah, sure.
Cool.
I think I got the answer.
Oh, happy days. Okay, let's run through it. So, what do you think you have?
I got 2.05212086.
2 point. Okay, let's check. So I'm just really quickly going to run through it and then explain. Okay, so we've got the hypotenuse is 6 centimeters. It's given to us, and we've got the adjacent, which we're trying to work out. So which of those triangles has both adjacent and hypotenuse?
Um,
Um,
the middle one.
the middle one, the cosine one. So that's going to be cos of 70, or cos of 70 at the bottom. You've got 6 for the hypotenuse, and this time you've got x as the adjacent. In this case, we're trying to work out x, and because we see these two things are next to each other, that implies multiplication. So that's going to be cos of 70 multiplied by 6, and that is going to be equal to 2.05212 dot dot dot, which is equal to 2.1 to 1 decimal place. And I believe that was, you said something along those lines. So you had that. So well done. I mean, you essentially picked up the topic of trigonometry, SOHCAHTOA, working out side lengths in less than half an hour. So happy days. You should feel, good about yourself. I hope you do.
Yeah.
Oh, that's good. Okay, you do good. You do feel good about yourself. That's good. um. Okay. If we go on slide 4, then there are just a few more questions to try. I'll give you maybe 3 minutes to try them. I know 3 minutes seems very tight, and it's like, what? 3 minutes to do 3 questions, but don't feel like you've got to rush. It's just I want to put a little bit of time pressure, just a little bit.
Should I label them?
It does help to label them, but if you want to do it on paper, you can, and then I can label them after. And what I'll also do is whilst you're labeling them and whilst you're doing the questions and everything, in fact, no, yes, you should label it because it's useful. It's good that you asked, actually. What I'll do is I'll prepare the next set of questions. Nice. Your labeling skills are 100. So I'll let you work through the questions on paper and then I'll go through.
I finished.
Oh, you finished. Okay, that was quite quick, actually. I know I said 3 minutes, then I decided, you know what? No, it's all good. So, first one, we've got the adjacent as 18 centimeters, and we've got the opposite as x. So, question, which one uses O and A? That's TOA. And in our TOA triangle, we've got T, which stands for tan 22. And then we've got the opposite, which is x. And we've got the adjacent, which is 18. So therefore, using that formula triangle, x is equal to tan 22 times 18. Are you in agreement so far?
Yeah.
Nice. By the way, if I do make a mistake, you're more than welcome to call me out on the mistake. Oh, there. That is not how you write the number that I meant to write. 7.2724 dot dot dot. So let's just go x equals 7.3 to 1 decimal place. Is that good?
Yeah.
Lovely. Thank you for saying that my work is good. No, I'm joking. So we've got the next question, which is the opposite, which is 2.8, the adjacent, which is x. So again, it's another question of opposite and adjacent. So we're using the TOA triangle. So we've got tan of 31, So we've got the opposite, which is 2.8. And then we've got the adjacent, which is x. So that means that x is equal to 2.8 over tan 31. Are you in agreement so far?
Yeah.
You sure? All good?
Yes.
Okay.
I think so.
You said you think so?
Yeah, it is. It's good.
Oh. So that means that x is equal to 4.6599 dot dot dot. Oh dear, that is a horrible dot dot dot. So therefore x is equal to 4.7 to 1 decimal place. Okay, and then quickly going through the last one. This one, we're trying to work out opposite, and we've been given the hypotenuse. So that's going to be O and H, which is the sine one. So that's going to be S is going to be sine. So S sine of 55. And then O is going to be X at the top. And then H is going to be 75. So X equals sine 55 times 75. Because the two things are next to each other, it's not a division. And then we've got 61.4 to 1 decimal place. Is that okay?
Yeah.
Nice. So give yourself a pat on the back. A pat on the back. Happy days. Did you give yourself that pat on the back?
Yeah. No, I did.
Oh, that's good. Yes. Cool. It's always good to, reward yourself and commend yourself. Cool. But we're not done yet. I mentioned that we can use trigonometry to work out side lengths and angles. So we've got slide 5. So on slide 5, notice how this time the x or the unknown is in the angle, not the side lengths. But we still start the same way. We start off by labeling the triangles. So I'll let you do that. Nice. Those labeling skills, it's really helped now because you basically advanced through this very, very, very well just because of being able to label. I've worked with so many students where they found the labeling really hard, but you're doing well. So well done. So with the first triangle, we're given opposite and we're given adjacent. Do you know which triangle we're going to use?
The Toa.
That's it, the total one. Now, question: what do we replace the T with?
Would it be tan x?
Very good. Yes, because this time x is the angle, and you've remembered that the sine cos tan is always of an angle, And in this case, it's x that's the angle. So tan of x. And then?
And then 3 on the top and 6 on the last one.
That's it. So 3 on the top, because it's opposite, and that's O. And then 6 at the bottom, because it's adjacent. And because x is what we're trying to work out, we would say that tan x is equal to 3/6. Now, at this stage, this is where we're going to do something that we've never done before. And so you know how with addition, the opposite of addition is subtraction?
Yeah.
And with multiplication, the opposite of multiplication is
Division.
And the opposite of squaring is
square rooting.
Yes. So every function, well, each of those functions have an inverse. And like with those functions, the tan function, the sine function, the cos function, they also have inverses. But it's not really a creative name. We just call it tan to the -1. So in this case, to get x by itself, we have to undo the tan function. And we undo the tan function by applying the inverse tan function. So we would say that x is equal to the inverse tan of 3/6. And on your calculator, to get access to the inverse tan function, that's going to be, you press shift first or second F, depending on what calculator you have, and then you press the tan button. Let me know if you're able to get that.
Yeah.
Happy days. And then you put 3/6 in. And then, of course, close the bracket after. Tell me what you get.
I got 26.56505.
Happy days. So let's just go to one decimal place. That's 26.6 degrees. So how's that?
It's quite simple.
Ah, that's good. I love the change of words there. Remember last time you were saying it's all right, but that's good. So with the next one, again, we've labeled it. Again, you've labeled it really well. You're given the hypotenuse and you're given the opposite. So which triangle do we use?
Would we use so?
Yes. So, emphasizing my H. So you've got the 4 and the 15. Oh dear. So you've got sine. Oh wait, actually, let me let you think about what's going to go in the triangle.
Would it be in the bottom left? It would be sin and then x.
Yes. Sin x, sine x.
The top one, it would be 4. And the bottom right, it would be 15.
Yeah, you got it. So top one is the opposite, which is 4. Bottom right is going to be the hypotenuse, which is 15. Happy days. Okay. And then, do you know what we would write next?
Sin x equals 4/15.
Yep, sine of x is equal to 4/15. And then, do you know what we do after that?
X equals sine to the power of -1. And then brackets 4/15.
Nice. One small thing, it's weird because it looks like it's to the power of -1, but it's not actually to the power of -1 because raising something to the power of -1 does something different. This notation is very, very confusing, but this notation is used to denote the inverse. So better to just say inverse sine, but that's a very, very minor thing. If you wrote that in your exam, you'll be fine. But just as a small thing, a small nuance, just to, use the proper nomenclature, as it were. So, inverse sine of 4/15. And we can compare answers. I've got my answer on my calculator. What's yours?
I got 15.46600995.
Nice. So I'm just going to say 15.5, correct to 1 decimal place. Happy days. You are on a roll, Krish. So with part C, maybe I'll give you a couple of minutes to have a go. Is that all right?
Yeah, sure. I have the answer.
You have the answer already. My gosh, you are on fire. Not literally though, because that wouldn't be good. So, um, so we've got. Okay, so the adjacent and the hypotenuse. So which one have both the adjacent and the hypotenuse? That's going to be cos. That's cos x. Then we've got the adjacent, which is up top, 8. And we've got the hypotenuse down here. Cool. Then we say cos of x equals 8/10. Then x is equal to inverse cos of 8/10, which is equal to, in fact, what answer did you get?
36.86989.
Happy days. Cool. And then that means x equals 36.9 to 1 decimal place. You've done well, Krish. So I leave you now on slide 6 to have a go at these final 3 questions, and then I'll ask you again how you feel about the topic. You okay to do that?
Yeah, sure.
Cool beans. How are you getting on, Chris, with the questions? Is it okay?
I'm on the last one.
Oh, nice. Okay.
I finished.
Happy days. Do you feel confident about your answers?
Yeah.
Okay. What we'll do is I'll write your answers and then I'll go through the method and then we'll see if they match. How do you feel about that?
All right.
You feel all right? Okay. So what was your answer for the first one?
For the first one, I got 53.130102.
And let's say if we have to do it to one decimal place.
53.1.
The second one?
I got to one decimal place, I got 69.5.
69.5. And for the third one?
To one decimal place, I got 61.
Like 61.0, kind of 61.
Yeah.
Cool. Okay, let's go through the methodology then. So the first one, we've got the opposite. And we've got the adjacent. So that uses the tan triangle. So we've got tan x. And then we've got the opposite, which is 12. The adjacent, which is 9. So therefore, tan x is equal to 12 over 9. Therefore, x is equal to tan minus 1 of 12 over 9. And drum roll. Oh, hold on. I'm just looking for my calculator. My calculator, my answer is 53.1. Yes. So that's one. Nice, nice. Happy days. And then going through the second one, we've got adjacent and hypotenuse. So we have the cos one because that's A and H. So we have cos of x. And then that's going to be 20 at the bottom right and then 7 at the top. So we have cos of x equals 7 over 20. And then therefore x is equal to inverse cos of 7 over 20, which is 69.5. Yep, your answers are exposed, but your answers are strong. And then lastly, we've got the final triangle where you've got opposite and you've got hypotenuse. So that's going to be the sine triangle. So sine of x is opposite, which is 42, and hypotenuse, which is 48. So we have sine of x equals 42 over 48. So therefore, x is equal to the inverse sine of 42 over 48. which to one decimal place is 61.0. Yes. So you got 3 out of 3 in those final 3 questions. Yeah, congratulations. I'm proud of you. You've learned trigonometry. You basically learned trigonometry in one lesson. Now just ask yourself, if you were in school, how many lessons would that take? And that's not a rhetorical question. How many lessons do you think it would take in school?
Probably 3 or 4.
Probably 3 or 4. Woo! And you did it in one lesson. How do you feel?
Good.
Yes, I'm glad. It's all about making people feel good and confident. One thing I'll do is I will send questions. In fact, I'll send it in the chat, but I'll also leave it on this Jamboard. So I've sent it in the chat, but I'll also put it on the Jamboard. And yeah, I would say do the questions. Wait, I'll write on the Jamboard what you need to do for practice. But yeah, we are done. Very, very nicely done. Yeah, again, just be proud of yourself because you learned that topic all in one go. Both side lengths and angles, and you know how to label the triangles, and you've basically come to grips with sine, cos, and tan, all 3 ratios. So what we'll do next week is we'll try to extend this a little bit just by looking at questions that look complicated, but in reality are not actually complicated. So yeah, I'll see you next week.
All right, bye.
Take care.